In this video, we are going to look at how to turn these mesh links into carbon rigid bodies and how to set up these belt loops to hold the belt in place. So the first thing we need to do is make sure our mesh links have their pivots centered and baked. Next, we need to check there are no intersecting mesh links. And I saw earlier that this link here is intersecting with its neighbor. So let's just fix that. For the cleanest simulation, we need to avoid any intersecting start meshes, be they rigid or cloth. Next, to turn these mesh loops into carbon rigid bodies, we can use the rigid body macro on the carbon shelf. Now, if we look inside one of these rigid bodies, we can see that they have several components. A rigid, which is a dynamic frame, a shape that defines the collision mesh, and a body that associates the rigid with the shape. This separation is a very powerful carbon feature that allows, for example, a shape to be shared with many rigids. So in this belt we could have just used one shape rather than 50. It also allows the use of a rigid without a collision hull, or the collision hull to be changed over time during fracturing, for example. Lots of cool functionality is opened up by this architecture. So next we need to set up the parameters on the rigid bodies. There are two main parameters we need to set up. The mass, which we are going to set in the rigid as 1 gram for each ring, i.e. 0.001 kilograms, and the collision parameters, which are set in the carbon shape. So for a rigid body, we want to use inner and outer fatness for collision. Thickness is really just for cloth. This fatness region is defined inside and outside the geometry surface and is the region that takes part in the carbon collision analysis. After we have created the carbon objects, we are not displaying the original geometry anymore, but the collision mesh that carbon sees. So let's have a closer look at the collision fatness on these rigids. If we select a ring and change to wireframe display and go into the carbon body and change the display color to something more obvious like red, and then go back into the shape, we can now visualize changes to the fatness. So if we change the outer fatness to 1 unit, the resulting collision region outside the geometry mesh is very obvious. This outer fatness surface is what carbon collides against. In practice, for a smooth, rigid body, assuming that we want the geometry surface to be the collision surface, we can make our outer fatness tiny, effectively 0. So let's set it to 0.001 units. Now with no outer fatness, the inner fatness is critical, and we should set it to the largest value available, which is just a bit less than the cross-section radius of the ring. Let's try 0.2. Visually, we can see that here as the lighter red area. This fatness helps carbon achieve accurate collision, and a small fatness requires more subdivisions to resolve accurate collision than a large fatness. You can see a lot of additional settings in these nodes, and you can check out their function in the documentation. Now we don't want to manually go through and set the mass and fatness for the other 49 rings, so let's use a Python script, and you can find this script in the tip of the day section of the Carbon forum on the website. Let's run the script and then just check that it's set the values we were expecting. All looks good. Next we are going to set up the simulation parameters. We want our scene scale in centimeters, so that's 0.01 meters. And we'll still need a reasonable number of subdivisions, as the chain is going to drop on the loops. So let's go with 30 subdivisions. We are also going to need some lead simulation, and we'll come back to that a little bit later. Okay, next, let's turn the avatar, pants and belt loops into carbon objects. Click on the avatar geometry and then the carbon collider icon, then click on the pants and the carbon cloth on the shelf, and the same with the belt loops. Now we need to set up some basic cloth parameters for the pants. We probably want to give them a thickness of, say, 1 millimeter, and remember we are in centimeters, so that's 0.1. Density looks good, and we probably want the stiffness a bit higher so they don't stretch too much. Next, we should bind the pants to the avatar, and to do that we need to click on the pants geometry, so let's hide the pants cloth node, as what we are seeing right now is the carbon physics draw of the pants. Now we can see the geometry. Next, let's select the vertices around the top of the pants geometry and then click on the carbon binding icon. Finally, in the carbon binding, select the avatar as the other mesh. That's it, we don't really need to change any other of the default values for the binding. Okay, let's have a look at the belt loops now. Reference meshes are a cornerstone of Carbon's power. By default, the reference mesh of a cloth is set to its start mesh. The first thing we are going to do with the belt loops is to set their reference mesh to the flat reference meshes we have here in the scene. To create these belt loops, we took those reference meshes and just stretched them out. Now, one beauty of reference meshes is that we don't care about their position in the world. All that matters is the relative position of the vertices to each other. So now when we run the simulation, these loops are going to try and take the form of their reference meshes, trapping the belt against the pants on the way. To make this a smooth process from this rough start pose to the physically correct start pose, we have a feature in Carbon called lead simulation. This is a stage before the first frame and can take place with or without gravity active. So let's set that up, and it's a bit trial and error to pick the right lead simulation length. But we don't need much for this scene, so let's set it to 0.2 seconds of simulation time. Also, it will be better if the belt is not initially falling down. So let's turn on stasis mode, which effectively turns off gravity during the lead simulation. Okay, next we need to bind the loops to the pants. We will use binding rather than stitching because there is no triangle alignment here to allow a nice stitch seam. First we go round and select the top and bottom vertices of each belt loop. Once we have them all selected, then we can click on the binding on the shelf and then add the pants as the other object for the binding. Now it looks like we might have missed that one, so let's select those vertices, hold Control and add to the existing selection. Now reset the simulation to confirm. Okay, let's run a few frames of simulation and see how we're doing. Okay, that's sort of working, but we haven't yet set up any parameters on the binding or the belt loops, so let's go do that. So the belt straps probably want to be a bit thicker, say 2mm, and denser, maybe twice the pants, 500 grams per meter, and a bit stiffer as well. Let's rerun that now. Looking good in some places, but a bit twisted here and there. Twisting of the belt loops is probably because we have not allowed any movement in the binding, so it's over constraining. Let's just give the binding of the belt loops a tiny bit of wiggle room, just a millimeter, and that will probably resolve the issue. There we go, that's much better. Oh, over here it looks like we have intersection between that loop and the pants. Let's just check by disabling the binding and see if the pant loops fall off. Yep, that loop is trapped in the pants. So to be safe, let's just fix that. All we need to do is to grab those belt loop end vertices and pull them out of the pants. Okay, looks like I made a basic error and edited the geometry output mesh position. You can see that here. Maya takes output mesh edits as additive. So to fix this, I need to edit the input mesh and then re-add the belt loop start mesh to the cloth, and re-add the reference mesh and reset the simulation. Okay, now let's run a few frames. There we go, looking good. Let's run a few more. Whoops, looks like the belt has broken through. Okay, it looks like the gap is too big. So let's go into the binding and fix the offset distance of the loop from the pants. To do that, we can use a surface offset here of 0.001. Now, if we rerun the sim, all looks good. So that's our example done. Thank you for watching, and I hope you find it helpful.